Alright guys, we're talking about residuals today, and so it's a pretty big topic. You're going to want to make sure you know what's going on. So take out your notes and you got residuals. So, residuals are one of the first principles of data analysis is to look for an overall pattern and for striking departures from a pattern. Basically, what the use of residuals is you can tell if a line would fit your data better if you use residuals. So we like to use residuals. So we say, hey, this might fit a line best. You know what? That actually looks like a parabola function. It basically zooms in on your data, and you can analyze it a little bit better from your perspective. A residual plot is a scatter plot of the residuals against the explanatory variable. Residual plots help us to assess how well a regression line fits the data. Alright, blah blah blah. Anyways, you guys can see here's following the notes. Here is your line that we've been working with a non-exercise activity and the fat gain. Here is what a residual would look like. Basically, what goes on is we take this red line and we flip it so it is exactly horizontal. Alright, so pretend that's the red line there. And then you can see if there is any other pattern. If there's really no pattern, and you don't see any pattern, then it would fit a line. So notice here, do you see any sort of parabolic look or anything in this? I don't think so. It looks like it's just random data points. If it's randomness, then it fits a line really good. You are actually looking for randomness when you're looking at a residual plot. All right. I know that sounds weird, but we're looking for randomness. All right. Interpreting residual plots. All right. A residual plot magnifies the deviations of the points from the line, making it easier to see unusual observations. Like I said, the residual plot should show no obvious pattern. Like, once again, we're not looking for a pattern. If you see a pattern on your residual plot, it probably would fit that pattern better. The residuals should be relatively small in size. So, for instance, here's a residual plot. What do you guys think? Does that look like it shows a pattern? Yeah, I think a parabolic shape might work best there. Okay, so I wouldn't want to use a linear regression line here. All right, that would be dumb. All right, next. And that came from this line here. So would I want to make a linear line for this pattern here? No, it actually looks like a parabolic shape. Actually, if you continue on through, you might actually continue to see some more writing over there. Sorry, my voice is going. Here's one last little thing. It says if we use the least squares regression line to predict the values of response variable y for the explanatory variables x, the standard deviation of the residuals is given. So we can kind of see what the average of all these little residuals are, and we can kind of estimate exactly um, what the average residual would be. That's basically what the standard deviation is. There's the formula. You would be pretty crazy to do it, but there it is. Anyways, all right. So let's get down to the brass and taxes. All right. So today we're going to be testing to see if there's any correlation between the hours a class is and the average grade in that class. So basically, does the hour matter on your proficiency in the class? So here we go. Let's pretend these are, let's say, Mr. Sheevy's hours. So first, second, third, fourth, fifth, sixth, seventh, and eighth. This is false data because I do have two preps. And also sixth hour. We all know sixth hour is just rocketing. I mean, just having an amazing time with a great average, like up in the 90s, I'm sure. Um, so here, let's say first hour, the average grade in that class is 75%. Second hour, average grade is 84. So, is there any correlation? All right, well, here's what I'm going to do. I'm going to pull my calculator, and you need to make sure you have your calculators out too as well. I probably should have said that at the beginning. All right, and I'm going to enter that data into my calculator. Now, by the power of television, I'm going to hit stat, and then enter. I actually already have those data entered into L1 and L2. All right, you guys good? Pause it if you need more time. Now, if I plot that sucker, I'm going to get something that looks like that. All right, if I actually go to stat plot, you'll see some line or some dots there. Boy, I don't know. What do you think? Do you think that would fit a line best? Oh, well, let's figure out what the equation of the line would be. All right. So, how do I find out the equation of the line? I'm going to go to stat, calculate. And remember, instead of one variable, we're doing two variables. Remember, hours and their grades. Do they correlate with each other? I'm going to press enter. Yes, x is going to be L1, y is going to be L2. And calculate that out. I will get a bunch of fun material. I was stupid again. I don't want this. Go to stat, calc. We want a line. We want to know what the equation of the line is. Oh, wake me up when September ends. You can either do linear regression, or you can do linear regression here. Now notice the difference. This is going to put your slope first and then your y-intercept. This is going to put your y-intercept first and then your slope. Technically, in statistics, we tend to use this equation more, so I'm just going to go down to 8 and use that form. Whatever floats your boat, I guess. Now I'm going to run this baby. All right, and I got my equation. Now, all you got to do, you got your A, you got your B, fill it in. All right, so we're going to see if we can do this here. All right, I am going to write here, as nice as I can, y equals, holy moly, is that large? Bear with me, guys. All right, y equals 0.818. Let's add the 6. We'll put a 6 there. Plus, I'm running out of room. Great. Ah. All right, let's do this down here. Plus. I'm just filling it in. Negative 0.0027. We'll say 4, just for kicks and giggles. And then we put the x. All right. One last thing you don't want to forget. This is our estimation line, so that needs to be y hat. You will not get that in your formula. Notice here your formula says y equals. Okay, you got to remember that y hat. Okay, so I just wrote out my equation of my line, and by the power of television, boom, I got my graph, and I got my line now graphed in there. All right, so here's the deal. Maybe that line doesn't work the greatest. That's possible. Well, how can we check to see our residuals? Now remember what our residuals are. Okay, our residuals are the distance from here to here. It's what I actually got, your y value, minus what you should have got, judging from our estimation. So it's the actual value minus what you should have got. That's the residual. Okay, and check out that residual. Holy moly. That gets a record. That would be y minus the y hat for that area. Okay, so all of these are residuals. Okay. All right, we're going to figure out those residuals. All right, you guys ready? How can we do this on our calculator? This is why I'm doing a video. All right, go back into stat, calc. This is sweet. If you, sorry, edit. Sorry. This is so sweet, guys. You probably never knew your calculator could do this. Press enter. Now, I want this over here to calculate what I should have got. Now remember, these values, L2, those are my actual values in my class. That's my actual percentages, right? Now, I'm going to have L3 be my equation for what my prediction would have given me. If I tried to predict it, what should I have gotten? Ooh. All right. So, um, I'm going to go up to L1, and you'll notice down here it says L1 or L3 equals. All right. Well, let's start typing some things in. What is our equation? All right. What is our equation of our line? And I'm losing it here. All right. Hold on. All right. My equation is 0.8186 minus, I'm going to put the minus there since it's negative, 0.0027. Then it's the x, correct? Well, what are our x values? Oh, they're L1, aren't they? Our x values are L1. So if I actually go over here and I press second L1, it's going to put all my x values in. All right? If I press enter, boom, shakalaka. Check that out. Those are what I should have got right here. Okay? I just put that equation up here into L3. These are what I should have got for y and my estimation. Okay? But we all know these are the real values. All right? So, I hope you can kind of see where this is going. So if I go back to my graph here, all right, the line is my prediction. All right, and this is what I predicted. I was off by all those green marks. Now, how do I figure out the distance of the green marks? Remember what the distance of the green marks are. Okay, and let me put it over here again. Y minus y hat, or my estimation. So it's my actual values, what I should have got, minus what I did get. Sorry, what I got, what I should have got. Oh, I'm so out of it right now, guys. I apologize. Let's go over and let's now go into my L4 and have that calculate my residuals now, all right? So I'm going to go up to L4, and where it says equals, I'm going to actually say, all right, these are the values I got. L2 is the values I got. So I'm going to go second L2 minus what I should have got. That's L3. Guys, what is that right there? Those are the distance of my residuals. Guys, it just calculated it all for me. Bada boom, bada bing in my calculator. Isn't that sweet? I love it. Those are my residuals. So, when I'm talking here, for first hour, all right, how far off was I? I was a good 6% off. Okay, do you see that? 6%. Negative 6%. See, I was below. Now let's go to the next hour here, all right? And I was a positive 2% off. 2.5% off. All right? Third hour is almost dead on. Fourth hour, I was 5% off, a little over 5% off. So you see how this calculated all of my residuals. I think that's really cool. I just think it's great. Now, how do we make the graph? Okay, so perhaps when you go to stat plot, because I want to plot this thinker, I'm going to go and press enter. I want it on. And then my type, I'm going to do a scatter plot. So I want to highlight that scatter plot. Now though, my x, I still want my L1 because those are my x values. It's my y that I want to change now, because instead of y, I actually want to know what my residuals are. Now, what column did we put our residuals in? I believe that was L4. Correct me if I'm wrong. I've been wrong a lot here today. So my x is still going to be L1, my x values. And then I'm going to put my residuals in. And then if I go and I graph this baby, graph it, okay, and then I probably want to go to zoom. And zoom stat is a really good, go and press 9. All right, now check that out. Now, basically what happened, this is my residual plot. What happened here? It definitely looks like there's a pattern. Can you see it? Looks like there's a parabolic shape. So I don't know if a line fits best to this. Um, you can kind of see, and let me erase all my junk here. You can kind of see that pattern here. The same pattern is written there. But what we did was we took this little line here, and we tilted it so it was basically like horizontal. And we can just kind of estimate a little bit better from from that. So that is our residual. So looking at a residual, you can tell whether or not it fits a line good or if it would fit a different shape better. Remember, if there's no pattern, you're good for a line. Excellent, okay? That's what you want. But if there is a pattern, watch out. Okay, well, that's my 2 bits. That's 17 minutes of Shivi, and have a great night, guys.